This research proposal is titled How Does Cyclist Speed and Location Affect the Passing Distance and Speed of Vehicles Overtaking? The goal of this presentation will be to give a high-level overview of the research proposal that has been detailed in the report submitted. Overall, this presentation will go through the motivation, identifying the core issues, showing the academic niche, the research methodologies, and then finally looking at some of the prototypes that have been built to show that this study is feasible. So first off, I will start off with the motivation. Cycling is a big safety concern. Cycling and cycling safety is a big concern of mine. Vehicles close passing cyclists is generally considered dangerous. As vehicles come too close to cyclists, this makes a perception of the road being dangerous. Road perception is one of the leading reasons why people don't cycle in Dublin. It may not be as dangerous as they seem, but the fact that they believe it is dangerous prevents them from cycling. A lot of the existing studies that have been done in this area have small data sets. This being primarily studies such as these are expensive to run due to the expensive equipment required to run them. On the other hand, studies that have used inexpensive equipment have often used video camera devices, which have led to researchers having to review hours and hours of data. So the core of the issue is, what is an overtaking maneuver? Here we have an example detailed below. There are 4 different stages. The first phase, when the vehicle sees a cyclist. The second, when they begin to move out of the lane or out around them. The third, the actual overtaking section. And the fourth, when they begin to move back in the lane. The part that we are really concerned with is it located in phase 3. It is the distance between the cyclist and the car. And this is what we define in this particular research proposal and experiment as the overtaking distance. There are many existing studies in this area, but as previously mentioned, they either use expensive equipment or required many hours of manual reviewing. I believe that there is an academic niche available here, a niche for a new methodology that combines using inexpensive parts with data processing. We should, in theory, be able to use inexpensive sensors that we can get online in the form of echolocation devices to be able to roughly identify when a vehicle is passing. This can then be combined with video recordings at the time. These video recordings then used to verify that yes, there was an event passing, as well as to extract extra information about the vehicle type and vehicle type. So the research methodology. Overall, the plan is to create the device, get a random section of cyclists to attach a sensor array to their bicycle. Then, over a period of 1 or 2 weeks, they will collect data of vehicles overtaking them on their daily commute. Doing this should give us a good insight into what the average cyclist experiences on a daily basis. I believe that the project can be made using cheap parts. Specifically, as detailed in the project specification, I believe the total cost of the build can be under €50. The most expensive parts in this whole project will be the camera device, the battery, and the actual microchip that is used to control all this. They represent €40 out of the €50 recommended. The sensors themselves normally come under €1 or €2 and are very inexpensive. By using multiple sensors, echolocation devices, we should be able to detect when a large object passes the bicycle. This detection can help us identify in the video automatically where we should look. Here is an early prototype we built. Here we see on the right, we see one sensor with a blue background with the 2 devices there, and on the left hand side we see the second sensor. This is the rough idea. We have early data as well here. Here we can see some of the early results. Located in green, here, show when a close pass occurs. In this example, we're only using one sensor. In the red here, we can see examples of when the device times out and no data is collected. Each of these green plots represents a close encounter with something passing the actual sensor. In the purple here, we can see generally noise. Overall, we'd most likely have to clean this data thoroughly before it could be used. So this is the overall plan for the project. I believe it's a feasible project as I've already built the prototype and we've already got rough data. The main purpose of the project will be to build a sensor device that can be easily replicated, and then to build a data processing system that can also be easily replicated. This in future would allow researchers to carry out the same study on their own and be able to change different variables in order to suit their needs. If you have any questions, please let me know. Thank you.